Today we're going to go over something called the zero product property, and we're also going to do more practice. But before we do that, we're going to simplify the following here. Simplify the following. I have 1 over 24 over 1 over 24. This is going to be equal to 1. For part B, I have negative 22 over negative 22. This is also going to be equal to 1. For part C, I have negative 0.75 over negative 0.75. Well, this is also going to be equal to 1. So there's a reason why all of these equal to 1. Why do all three examples above reduce to the same value? They all equal 1. So what do we notice about the top? And what do we notice about the bottom? They're the same. So I can say because the top and bottom of each are the same. Top and the bottom of each are the same. All right, let's go ahead and fill in this table to look for a pattern. Fill in the table below and look for a pattern. So this column, we have the original product. This middle column, we have the expanded form. And this last one, we have the single power. So let's look at the first one. We have 2 to the 4th over 2 to the 4th. So I'm going to expand it out. If it's 2 to the 4th on the top, then I have 4 2's multiplying each other on the top and 4 2's multiplying each other on the bottom. If I see there are things that are the same on the top and the bottom, I can cross it out. Now when everything crosses out, it doesn't equal 0. It's going to equal 1 here. Just like what we saw on the top. When the top and the bottom are the same, it's going to equal 1. Well, now let's look at the next row for expanded form. We have 5 to the 6th and 5 to the 6th. So that's 6 5's on the top. 1, 2, 3, 4, 5, 6. And the same amount on the bottom, because at the bottom is also 5 to the 6th. And then again, if it's the same thing on the top and the bottom, it's equal to 1. And then finally, the last one, a to the 3rd over a to the 3rd. So then I have 3 a's multiplying each other on the bottom and the top. Same on the top and the bottom again. So it's going to equal 1. So that's what we're seeing from expanded form. Let's see what it looks like if I rewrite it as a single power. So going back to what we have in that first row, these are all quotients. If they're all quotients, then I have to use the quotient property. The base of each of these are 2. They're the same base. So I can subtract my exponents of 4, which is 2 to the 0. So this is it as a single power. Similarly, for the next one, we have 5 as the bases. So I can rewrite it as 5 to the 6 minus 6, again using the quotient property. So that's going to give me 5 to the 0. And then the last one in the row is a to the 3rd over a to the 3rd, same base of a, exponents of 3. And I have a to the 3 minus 3, which is a to the 0. So they're the same original product, but the expanded form and single power look different, but they are equal. So then I can go ahead and say 2 to the 0. Well, that's equal to 1. 5 to the 0, also equal to 1. A to the 0 is also equal to 1. So all of these that are to the 0 power equal 1. Based on the pattern you observed on the table, write the missing exponent in the box below to complete the 0 power property for exponents. A to the 0 has to equal, based off of what I saw up here, what do all the 0 powers equal? All the 0 powers equal 1. So in my own words, I'm going to say any base to the 0 power always equals 1. But I have to be mindful, what is the base and which base has the exponent 0? Because not all bases have an exponent of 0. Let's see what I mean by looking at these sample problems. Try these, simplify the following expressions. So based off of what I just saw on the top, I can do A pretty easily. 9 to the 0 is equal to 1. Let's look at part B though. Part B is a little different. There's a 6 in the front of that x to the 0. There's an invisible exponent that 6 has. It's 6 to the first. There's an invisible 1 there. So that means I have 6 to the 1, which is just 6. And then x to the 0 is going to be 1. So this one's a little different because it becomes 6 times 1, which is 6. So the base with the power of 0 was just x. 6 does not have a power of 0, so it stays 6. Let's look at C. Now when I look at this one, I see that exponent of 0, but what is the base with that 0? The base is this whole thing, 1.5x. So because the whole thing has a power of 0, I can go ahead and write 1. For part D, I need to do a certain property first. These are being multiplied and they both have a base of x. So that means I'm going to use the product property and I'm going to add my exponents. I have 7/4 plus negative 7 over 4. And that is going to give me x to the, if I put that in my calculator, I'm going to get 0. And then x to the 0 is equal to 1. Let's look at these next ones for more practice. Simplify each expression. So I think I'm going to start by just rewriting the things I can that maybe will change and do not change. So for part A, I see 4x to the y to the 4, negative 2x squared, and y to the 0. If I see something that has something to the 0 power, I'm going to go ahead and write 1 in place. And if it has a 1 there, if I'm multiplying by 1, it doesn't really change it. So I actually don't even need to write it. I can just go straight to doing this. At this point, I'm going to simplify. That means I'm going to put together the things that are the same or similar. So like 4 and negative 2. Let's put that together. For the x's, we have x to the first. There's an invisible 1 there, and x squared. And then finally I have that y to the 4th, and there's no other y anymore because that 0 went away. Negative 2 times 4, or 4 times negative 2 will give me negative 8. For x to the first and x squared, I can use the product rule. 1 plus 2 is 3. And then that y to the 4th will stay y to the 4th. Okay, let's look at part B. So for part B, similarly to what we saw in A, if there's something that has a 0 power, I can go ahead and just change it to 1. So that's just going to be equal to 1. And if I have 1 and 2 multiplied, it's just going to be 2. So I don't need to write the 1. It's just going to be 2 times b to the 5th times c over 4ab squared c. And then I can go ahead and do it like normal. Now for part A, I did it by using the rules. What if for part B, I started expanding it out? So 2, and then there are 5 b's. 1, 2, 3, 4, 5, and 1 C. 4 A, and then there are 2 B's and 1 C. And now I'm looking for things that I can cross out. So these C's are going to go away. 2 pairs of B's. What else? I also see 2 over 4. I could put that in my calculator and reduce it to 1/2. So then what's left on top? I have 3 b's, so that's b cubed, or b to the 3rd, and on the bottom I have a left. And usually if I have 1, I don't need to write it. So I'm going to go ahead and simplify this one more step on the top. 1 times b to the third is b to the third. And then 2a is just 2a.